previous 3 lectures what we've seen is the particulate nature of matter. And in the process we've unraveled the atomic structure. And where we stand right now is the Bohr's model. So all of what we've seen so far tells us that energy is quantized. And matter is made up of discrete particles like electrons, protons, and so on. But whenever the energy levels are quantized, for example an energy level E1 and an energy level E2 and an electron, which is now a particle according to Thomson's experiment and so on, when this electron makes a transition from E2 to E1, a photon will be emitted of a particular frequency, omega. So what is the nature of this photon? So whatever is emitted is called radiation. And we would like to explore what is the nature of this radiation, whether it's a particle or whether it's a wave. We've seen that matter is particulate. So if I write matter here and I write radiation, I write particle here and I write wave here. So what I'm trying to do in my lectures now is to highlight whether matter is a particle or a wave, whether radiation is a particle or a wave. So what we've seen is that matter has particulate existence, it has a grainy existence, that electrons, neutrons, protons exist and they are arranged within a certain configuration inside the atom. What I'm going to talk about today is starting to talk about the wave-like nature of radiation, and I would like to highlight what is meant by a wave. And later I'm going to see whether I can put a tick mark here and if I can put a tick mark here. And then I would like to explore what's the concept of a particle, the meaning of the word particle and the meaning of the word wave. And this is the starting point of quantum mechanics, starting point of quantum physics. And this is one of the greatest departures from classical physics. Classical physics treats matter as a pure particle. It has a grainy existence and everything is particulate. Radiation, on the other hand, there were 2 theories, whether radiation is a wave or whether it's a particle, and both of these theories stand on solid grounds. So we would like to synthesize all of this. Synthesize का मतलब समझते हैं? We would like to combine all of these concepts and package it into one. Because one of the basic goals of physics is unification. Unification means to look at apparently different phenomena and try to write very few equations, very few principles that explain all of these phenomena. For example, we've seen the second law of thermodynamics. The second law of thermodynamics tells you why you cannot draw energy from the Indian Ocean. The second law of thermodynamics tells you why a bouncing ball finally comes to rest. The second law of thermodynamics tells you that energy has to flow from a hot body to a cold body. So all of these phenomena look really different when you look at them. But they are explained by just one principle. Entropy would like to maximize itself. That's it. So this is the idea of unification. So we would like to unify the particle and the wave descriptions of matter and radiation. But first of all, we have to understand what is meant by a particle, what is meant by a wave. So what I'm going to start now is looking at the characteristics of waves. So when you start using the word wave, I would like to ask you, what comes to your mind as a first reaction? How would you define a wave? Please raise your hands. आप बताएं, सबसे आखिर में बैठे हुए हैं आप जी. It's a disturbance across any medium. It's a disturbance. Is it any kind of disturbance? I'm putting a disturbance on this table. Is this a wave? It's not. आप बताएं जी. It's the propagation of energy. Is that all? I'm moving this table. Energy is moving. I'm propagating energy. Is this a wave? Yes. Without the disturbance of matter. Without the translation of the medium. These carriers of? There are some carriers of energy. Okay, anything else?
A wave is a disturbance in the medium in which successive particles execute periodic motion and transfer energy from one part to another.
That's good. That's a very textbookish definition, but it's correct. That's fine. So all of you have an idea of what a wave is. So in a wave, you see, English language comes before physics. Even when there was no physics, or the physics as we know it today, still English language existed. So wave is an old word. So when we use the word, it conjures certain ideas in our mind. So when we say a wave, something has to wave in a wave. There has to be something that is waving, some undulation, and that is periodically arranged. That disturbance is periodic inside the medium, and as that disturbance periodically moves forward, energy is transferred. But there has to be some periodicity associated with the wave in most cases. So if I would like to ask a student of class 9 or 10 to draw a wave, what he or she would do would probably come up with a picture like this, right? You would draw this picture, but there has to be something that is waving inside the wave, right? So this wave is a noun and this waving is a verb. There has to be something that is waving. So every picture in physics has two axes, a vertical axis and a horizontal axis. So what is the vertical axis here? It's that property that is waving. That is the vertical axis. It could be anything. It could be pressure when sound waves pass through a gas. It could be the height of a bob placed on the ocean and ocean waves are passing through the ocean. It could be something associated with light. For light, this is the electric field. Okay? So something has to wave. And what's the horizontal axis here? Time or distance. So this horizontal axis, this axis, could be time or distance. And this vertical axis is something that waves. And the height, this is a very neat wave. It's sinusoidal. But waves need not be sinusoidal. And the maximum height for a sinusoidal wave is called the amplitude. So suppose I take this to be the distance axis. I call this x. And I call this variable y. And if this is sinusoidal and looking at 0, x equals 0, the height is maximum a. What will be the equation of this wave? A. So y equals a cosine of omega x. Omega is a very wrong variable to use here. It's not, omega is fine, you can use omega, but it's not a good choice. It has to be, let's call it kx. I will tell you why you should use avoiding the word, the variable k here. Okay? Now this is a picture of a wave taken at time t equals 0. Okay? So I have a camera and I set the time t equals 0 and I immediately take a picture of the wave. This is what I get. And the wave is waves along the x-axis and the time is frozen. We are frozen in time and we're looking at the wave as it is distributed in the spatial dimension. So the equation for this picture will be a cosine kx. Now what is this k? Could you tell me what this length is called? This length is called the wavelength. The wavelength is the period in space. Okay? And is there some relationship between k and lambda? Could you write this wave wave in terms of lambda instead of k? Could you please write it down for me? Look at the graph and write it down.
7.
ज़हन के सफ़े पे नक्श करे. वाह. You don't have to remember any formula. You just need to see what the value of the function is when x is equal to lambda. What's the value of the function at x equals lambda? It's maximum a. So there's a graph that has a period lambda. So you would like to write the equation for it. ये अपने A levels में पढ़ा होगा इस तरह की कोई चीज. मॉडर्न फिजिक्स में कोई नई चीज नहीं आप पढ़ेंगे.
2 pi x whole lambda. 2 pi x.
This is equal to a cosine of 2 pi x over lambda. When x equals lambda, you are at this point, cosine of 2 pi is at its maximum value. When x is lambda by 2, which means you are here. At this point, this is lambda by 2, cosine of pi is -1, so your amplitude is minus a. When x is lambda by 4, you put lambda by 4 here, this becomes pi over 2, cosine of 90 degrees is 0, you are here. So this is your equation, or this is the expression for this wave that I've drawn here. It's not difficult. Now another example. This is a spatial portrait, a portrait in space, a picture taken at a fixed time. It's called a spatial portrait. ठीक है, portrait है ना, ये एक चीज को खड़ा कर दिया आपने, उसका portrait है, आपने image लिया है at some point in time. Okay, you understand this? Now another thing I could do, I could stand at a fixed point in space and there are air waves that are coming. I close my eyes, I don't see anything, but I see the air waves passing through my body. So I'm standing at a fixed position in space, but now there is some energy that is coming in my body, going out, coming in my body and going out. So I can take a time portrait as well, because energy is being carried from one point to the other. So if I fix the value of x, I can also make a plot of y versus time. So if I have the time axis and I have y, now I can draw a graph between y and time. There is no harm in doing that. So this is a graph at a fixed value of x, say x naught. So this is also a picture of the wave. It's a time portrait. This is a spatial portrait. Okay? क्योंकि आपने खुद ही कहा था कि this axis can be time or distance. So if I draw this wave with respect to time, I can also get a similar graph. I will get a similar graph. So I close my eyes and I let, for example, I'm on a boat and there are water waves going through the boat and I'm taking a nap. I've just closed my eyes. My boat is static, and with time my boat takes an upward hump, goes down, upward hump goes down, upward hump goes down. So I'm undergoing wavy motion with respect to time, but my position is fixed. So I can plot that wavy motion with respect to time as well. Okay? So this plot is y versus x. And I can also plot y versus time. Could you tell me what the expression would be for this kind of portrait? It's going to be a cosine of omega t. Okay? Now this omega is related to the time period, the period in time. That k was related to the period in space, inverse relationship with the period in space. Here this omega is inversely related to the period in time. So this becomes a cosine of 2 pi small t divided by capital T. This is omega. Okay? Alright, so everything should be very clear. It's very simple up to so far. Now I make another diagram. Let's call this x, and I have a variable y here. Now I plot the wave at time t equals to 0. This is at time t equals 0. This is a spatial portrait, remember. Now what's happening is that with time all of this wave is moving forward. Alright? तो अब जब कुछ वक्त गुजर जाएगा तो ये वेव अपनी जगह साकित तो नहीं है, it's carrying energy. So the wave is traveling from one end to the other end. Suppose it's moving from left to right. So if I have taken a picture at time t equals 0 and now I take another picture after a time t has elapsed, so I will get a new picture, a new spatial portrait. And for example, this wave will go here, will have advanced to the right by a certain amount of time. So this is a picture of the same wave at time t, which is greater than 0. Okay? Because the wave is moving forward. Now suppose the wave is moving forward with a speed. Every wave has a speed. It's moving with a speed v towards the right. Now for such a wave, can you use your common sense, your intelligence that God has given to you and write an expression for this traveling wave which is moving forward with the speed v?
Is it Vt minus negative?
You're on this right track, but this is not the correct answer. स्पीड dv है, और जिस तरह ऊपर इक्वेशन लिखी है a कोसाइन ओमेगा t, a कोसाइन के x, इसी तरह इसकी भी इक्वेशन लिखनी है. आप लोग चीजों को मैथमेटिक्स में उलझा देते हैं. आप डेरिवेटिव निकाल रहे हैं. आप इस तरह नहीं करें, आप ग्राफिकली देखें पहले चीजों को. पहले पिक्चर्स की जुबान समझें, वर्ड्स की जुबान समझें, फिर इक्वेशंस की जुबान में बात करें. डेरिवेटिव लेने से आंसर नहीं आएगा आपके पास. प्लस आएगा इधर. माइनस वी टी ओवर लैम्डा क्या होगा? पूरी इक्वेशन लिखो. एक cos 2 पाई ओवर Let me give you a hint. अगर ये x एक्सिस है ना, अगर ये वाइट ग्राफ, अगर मैं रेड ग्राफ की वही इक्वेशन लेना चाहता हूं जो वाइट ग्राफ की है, ठीक है, तो मुझे x एक्सिस को छेड़ना पड़ेगा थोड़ा सा. मैं क्या करूंगा, तो रेड इक्वेशन की वही, रेड ग्राफ की वही इक्वेशन आ जाएगी जो वाइट ग्राफ की है. मैं x एक्सिस को क्या करूंगा, थोड़ा सा शिफ्ट कर दूंगा टुवर्ड्स द राइट, कि मैं एक नया x एक्सिस बना लूंगा जो यहां से शुरू होता है, राइट? एक नया x एक्सिस x डैश जिसका ओरिजिन यहां पे है. तो फिर क्या होगा, फिर ये होगा कि y की एक्सप्रेशन एज x डैश विल बी a cosine of k x dash. Okay, I just changed the origin, nothing else. I've shifted the axis. Now is there some relationship between x dash and x? What's the relationship? बताओ माहिर, आप बताओ क्या है relationship? Is equal to x dash. So what I've done is I've changed the axis a little bit so that x dash is really x minus vt. So this is the expression for the red graph, for the traveling wave. This is the expression for the traveling wave. A wave that is traveling towards the right is given by cosine of k into x minus vt in brackets. It's just a change of the origin of the axis. Okay, so the equation is for a traveling wave that is moving towards the right is given by a cosine of k x minus vt. When time is 0, this time is 0, you get the white curve. When the time has advanced, this number becomes positive, x minus vt becomes negative. So you get the red graph. So this is the equation for the traveling wave moving forward, moving in the forward direction. And when x equals vt, if you look at the red graph, when x equals vt, for example, you get this point here. So you get the value of the white graph v time t earlier. So do you understand how I've written this graph? How I've written this equation? No? Not at all? इसकी समझ आई? x dash इसकी समझ आई, x minus vt. समझ तो आ गई है? नहीं, इसकी समझ आई आपको? आ गई? x dash equals x minus vt, इसकी समझ आ गई? Now if you look at this equation, what if x equals vt? Now if you put in the expression x equals vt, y x equals vt, this becomes 0. Oh sorry, a cosine of 0 is 1. A cosine of 0 is a. So at x equals vt, what point on this graph is x equals vt? This point. At this point, this variable x equals vt. Okay? So at this point, the value of the wave is at its peak. So you can put in some sample representative values and verify that this is indeed the equation of a wave that is traveling towards the right.
So why are you subtracting vt? Why not adding it?
So this is a test case. If I put x equals plus vt, I am at this point, right? Now what is the value of x here? What is this distance? It's vt, right? Because the wave is moving forward with the speed v, and in time t it moves this distance vt. So what is the value of x here? Vt. And what is the value of the wave? It's not 0. What's the wave amplitude here? It's equal to the amplitude a. So I put x equals vt here. I get k times 0, which is 0, and the answer is a. Alright? If the wave is moving in the opposite direction, what will be the equation? Right, I will just have y of x equals a cosine of kx plus vt, and you should be able to verify this. This is the wave that is moving towards the left moving traveling wave. So this is the expression for a rightwards moving wave. It depends upon x as well as time. So I can put a time here as well. Okay? So this is the equation of a traveling wave with respect to both position and time. Now it's very convenient in physics to write these trigonometric functions in terms of exponential functions. Have you studied complex numbers? Yes, you have, right? In some course, in calculus 1 perhaps. Has everyone studied complex numbers? Has anyone not studied complex numbers? ये सब लोग गवाह रहे हैं. Everyone has studied complex numbers. ठीक है? तो इसे बाद में मुझे नहीं आप कहना. ठीक है. So complex numbers. So if I have this expression for a traveling wave, a cosine kx minus vt, then I would like to expand this a little bit. I can write k cosine of kx minus kvt. Okay? Now for a wave, we know that kv can be simplified further. K is just 2 pi over lambda. It's 2 pi over the period in space, and v is the speed of the wave. Is the speed related to the wavelength? Yes, it is. And what's the relationship? It's f is the frequency, lambda. So this becomes 2 pi f, which equals omega. So this expression can also be written as a cosine of kx minus omega t. Okay? So if I have an expression of this form, there is a coefficient with time, and that coefficient will be 2 pi over the period in time. There is a coefficient with x, and that coefficient will be 2 pi over the period in space. Which means that time is inversely related to frequency, or the time period is inversely related to the frequency. This is frequency. Okay? This is a frequency, and this is time. This is space, right? X is space. खला नहीं है, 3-dimensional space की बात है, x, and this has to be some analog of the frequency in space. ठीक है? जिसका period is the wavelength. K can be given different names. It's called the spatial frequency. It's also called the wave vector. So time and frequency are kind of opposite variables. Time period goes up, the frequency goes down. Likewise, x, distance, and spatial frequency are opposite variables. Okay, so these are called conjugate variables. Now we have this expression for the traveling wave, a wave that is moving towards the right. Sorry? Sorry? Time and frequency, position and spatial frequency. बाहमी तौर पर ये स्पेशल आपस में कॉन्जुगेट है. टाइम का कॉन्जुगेट फ्रीक्वेंसी, स्पेस का कॉन्जुगेट स्पेशियल फ्रीक्वेंसी. तो इफ यू लुक एट दिस एक्सप्रेशन इज, if I write a e raised power iota kx minus omega t, what's the relationship between what I've written here and what I've written here? मैं जिससे पूछूं वही बताए. किसी को पता है इन दोनों में क्या रिलेशनशिप है मैथमेटिकली? कॉम्प्लेक्स नंबर्स पढ़े हुए हैं ना? यार आपने वाकई कॉम्प्लेक्स नंबर्स पढ़े हुए हैं? आइलर फार्मूला नहीं पढ़ा हुआ. ठहरो एक मिनट, आप पीछे बैठे हो, आपको पता है क्या रिलेशनशिप है? अच्छा, मुझे बताना पड़ेगा मेरे ख्याल में. आपको पता है ई रेज़ पर आयोटा थीटा का क्या मतलब है? नहीं पता. If I write a number a plus iota b, इसका पता है? This is a complex number, right? Z, some z. Now this number can also be written in this form. E raised पर, e का पता है ना सारों को? Iota theta. This number and this number both represent the same number. This is one expression, this is another expression. This is called a rectangular expression. ठीक है, rectangular. And this is called a polar expression of the same number with some magnitude. R is a real number and e raised by iota theta. And there is a theorem which says that this number, the exponent of an imaginary number, theta is real, r is real. This number, this exponent is given by the cosine of theta, right, plus iota times sine of theta. Now r is real, okay, theta is real, cosine theta has to be real, theta is real, sine theta has to be real. So if I just look at this number, okay, let me write this as r cosine theta plus iota r sine theta. Is this real or imaginary? Real. Is this real or imaginary? Purely imaginary. So if I take the number z and I would like to find the real part of it, the real part of z is this number, or the real part of r e I theta is r cosine theta, okay, and the imaginary part of the number is r sine theta. Okay, is everyone with me on this point? अच्छा, A levels में कॉम्प्लेक्स नंबर्स होते हैं? मैंने A levels किया नहीं, मुझे पता नहीं. होते हैं?
रेक्टेंगुलर में होता है पोलर में।
अच्छा, और सब ने मैथ्स पढ़ा हुआ है, लेकिन कैलकुलस 1 में नहीं पढ़ा इस तरह की कोई चीज। ठीक है, अब हम अप्लाई करेंगे। ठीक है, चलो ये एक रिवीजन हो गई। अब आप मुझे ये बताओ कि ये नंबर है, ठीक है, इट्स अ कॉम्प्लेक्स नंबर written in the polar form. Remember that this number is not different from this number. They are the same number but written in different forms. ठीक है, फॉर एग्जाम्पल मैं उसकी मिसाल देता हूं आपको समझाने के लिए, थोड़ा मैं मैथ्स का टीचर बन जाता हूं। ये एक वेक्टर है A और ये एक वेक्टर है B, ऑल राइट, और इन दोनों के दरमियान 90 डिग्रीज का एंगल है। तो एक तरीका ये है कि आप वेक्टर A बता दें कौन क्या है, उसकी लेंथ क्या है, और वेक्टर B बता दें उसकी लेंथ क्या है, और ये अंडरस्टूड है कि इन दोनों के पास 90 डिग्रीज का एंगल है। दूसरा तरीका इसी डायग्राम को बनाने का ये है कि आप सिर्फ इनका हाइपोटेन्यूज बना दें इस ट्राइंगल का, और बता दें कि ये हाइपोटेन्यूज A वेक्टर से कितने एंगल पर है। This picture is the same as this picture. If I give you vector A and vector B and I tell you that both of them are normal to one another, I have provided you with some information. But another person could come, he could not give me individually the values of A and B. He could tell me what the hypotenuse is, what the length of the hypotenuse is when A and B are connected, and what the angle does the hypotenuse make with A. Okay, so this length will be R and this angle will be tan inverse of B over A, and this R will be A mod squared plus B mod squared, right? So one can either tell me R and theta, or one can tell me A its length and B its length. So this is the rectangular picture, this is the polar picture. You can provide me with R and theta and my number would be R into e raised per I theta, or you could give me A plus iota B, one of the same thing. So this number Z is just one number. It can be represented in two ways. Okay, so now if you look at this complex number, can you tell me what the relationship between this complex number and this real number is? This is just the real part of this. Okay, so this physical wave for which I have written an equation is just the real part of a complex number, and it's generally easier to deal with complex numbers in physics. Why? Or with exponential numbers. Why is it easy to deal with exponential numbers? Any ideas? Please raise your hands. हाथ खड़ा करें। वहां से कोई बता सकता है कि why are exponentials easy to deal with in mathematics or in calculus? कोई बताए, सोच लें, there is no hurry. चलो आप बताओ। Right, they are easy to differentiate. You differentiate e raised power x, it's e raised power x. You integrate e raised power x, it's e raised power x. So it's very easy to do differential calculus. You differentiate or integrate, the answer is again an exponential with some scaling factor, of course, but sine has to be converted to cosine when you differentiate, cosine has to be converted to sine when you differentiate, so you have to remember. but it's easier to remember that something doesn't change. So that's why exponents are easy to deal with. And therefore, instead of looking at this physical form, at this physical expression, one can alternatively deal with the complex number. And in the mind you can remember that at the end we have to take the real part of the complex number. That is the physical result. So this expression is physical. This expression is mathematical. So you can do all your maths with this expression, and in your mind remember that, alright, right at the end or at any point I like, I have to take the real part. Okay? Because it's easier to work with exponential numbers. Now I would like to write an equation which is called the wave equation. Last 5 minutes. देखो हम 2 लेक्चर्स में कैरेक्टरिस्टिक ऑफ वेव्स कंप्लीट करेंगे. फिजिक्स के अंदर सिर्फ 4-5 इक्वेशंस हैं. ठीक है, आप फॉर्मूला शीट मांग मांग के थक जाते हैं, लेकिन फिजिक्स के अंदर सिर्फ 3-4 इक्वेशंस हैं. न्यूटन्स लॉ है, वेव इक्वेशन है, हेल्महोल्ट्ज इक्वेशन है, हीट इक्वेशन है, दैट्स इट. वो सारी उस और मैक्सवेल्स इक्वेशन, वो सारी की सारी न्यूटन्स लॉ से निकलती. इक्वेशन ऑफ मोशन में कोई नई चीज नहीं है. तो ये सिर्फ 3-4 इक्वेशंस हैं फिजिक्स के अंदर बेसिक. इनके अलावा कोई इक्वेशन नहीं. और क्वांटम मैकेनिकल इक्वेशन है श्रोडिंगर इक्वेशन, उसका रिलेटिविस्टिक वर्जन ले लें डायराक इक्वेशन. दैट्स इट. तो अब एक वेव इक्वेशन वेव्स को एक्सप्लेन करती है. If let me write down the wave equation. Do you know the partial derivative symbol? Yes. No, okay. Let me write down the wave equation without getting into the mess of partial d square y over dx squared is 1 over v squared y over dt squared. Now this is the wave equation. A solution means find the value of y as a function of x and time. So this differential equation will be solved to give you a solution, and that solution will be the wave. In other words, the wave satisfies this differential equation, which is called the wave equation. Now the left hand side is the double derivative of y with respect to x. The right hand side is the double derivative of y with respect to time, and with the speed here. First of all, remember it's dimensionally correct. What's the dimensions of the left hand side? No dimensions, none. Of the right hand side, none. This is meter square per second square. This is second square per meter square. So none. So it's a dimensionally correct way of writing the wave equation. Now I would like you to show me that if my wave is given by this expression a e I raised to power kx minus omega t, if this is my wave, which is simply this mathematical form of the wave that we have derived, then this wave, you put it into the differential equation, the differential equation is satisfied, which means that this will be a solution of this equation. So could you please do this for me? First work out the left hand side and then the right hand side. Quickly do this for me, you don't have much time. Show me that this is a solution of the wave equation. You have to show me that this is a solution of this equation. I'm not asking you to solve the equation. I've given you a solution, and you should at least tell me whether it is the solution or not. It's a correct solution or not. If I give you x square plus x equals 3, I'm not asking you to solve this equation, I'm giving you an answer, a tentative answer, and asking you to test whether it is a solution or not. आसान काम दे रहा हूँ आपको. बिल्कुल नहीं समझे. पहले ये तो कर लो. कैलकुलस 1 में डिफरेंशिएशन तो पड़ी हुई है ना. शाबाश. शाबाश. That's fine. A is equal to this. Okay, if I look at the left hand side is d squared y over dx squared, d squared dx squared. What is y? A e I kx minus omega t. I differentiate this once first. I write d by dx. I differentiate it once. I get a. The derivative of this is ik times e I kx minus omega t. And then I differentiate again. I get a ik squared, which is minus k squared e I kx minus omega t. Right? And if I look at the right hand side, the right hand side, remember in this differentiation I am assuming time to be constant. Okay? So this really means differentiate y with respect to x assuming time is a constant. This means differentiate y with respect to time assuming x is a constant, for partial differentiation. So the right hand side is 1 over v squared d squared dt squared y, which is a I kx minus omega t. 1 over v squared d by dt a minus I omega e I kx minus omega t. I differentiate. Okay, let me go here. Right hand side continued is 1 over v squared a minus I omega once again e I kx minus omega t. This is a, this is I square omega squared, which is minus omega squared e I kx minus omega t. I hope you know I square is minus 1. So now this is the right hand side, this is the left hand side. Are the two equal?
Yes.
They are only equal if k squared is omega squared over v squared. But haven't we seen this earlier? Oh yes, we have. You see, kv equals omega, which means k square V squared is omega squared, which means kV equals omega. So this is correct. This is correct. So this indeed is a solution of the wave equation. And the Schrödinger equation is a quantum mechanical version of this equation. So in the next lecture, we're going to have a demonstration on interference, and I'm going to tell you something very interesting about waves. So see you on Tuesday, inshallah.
See you.
Yeah?